Hello, everybody, and welcome to another RxM Cloud Native Short Take. This is Christian Lacsina from RxM, and today I'll be short taking the basics of the Kubernetes job, informing you on what they are, what they can be used for, and of course, demonstrating how to create them. Jobs are a type of controller in Kubernetes that allows users to define one-off tasks to be running within Kubernetes pods. These tasks are meant to be short-lived application runs meant to exit once some kind of goal is reached. And so the pods themselves are meant to run and then exit, showing the completed status. This is in contrast to deployments, which run their applications and always keep them running. So jobs will run their pods up until they exit. Jobs are great for a few things, like cleanup jobs, such as clearing image caches or rotating logs on a host. They're also great for processing or deleting messages from message queues. And they're also really good for doing on-demand calculations, which is why you might see jobs often used for serverless implementations that are run on Kubernetes. So now that we know what jobs are, let's take a look at a sample job. So I have a sample job right here, and I've broken it down into 3 different categories. We have our API identifiers, of course. That's going to define what kind of object we're creating in Kubernetes and how we can find it in the API. Next, we're going to have the spec, and this is where some of the job-specific settings are going to be coming in. The goal of the job are one of those things, such as the number of completions, which I have defined here. Next are the number of pods to run in parallel if you wanted that to happen. And so I've got that defined as 2. And I don't have this shown here, but also a retention period before automatic removal of the job, which is something I'll be addressing when we demo it shortly. Finally, there's the pod specification. If you're familiar with Kubernetes deployments, then you'll know that this pod specification is defined under the template, and everything that you might know about a Kubernetes pod is going to apply here. This is an embedded pod specification, so every field, aside from the metadata name, is valid. There is one caveat to this pod spec, though, in that the restart policy must either be on failure or never. So you don't want the kubelet to try and recreate any containers that have exited, because that is the yardstick that the job uses to consider itself finished or still in progress. Let's go ahead and take a bit of a demo and see how we can use jobs. All right, so I have my Kubernetes cluster right here. It's a 3-node cluster with mixed architectures, one with a Raspberry Pi in it. And I also have the job YAML that I showed on the slide here. So let's go ahead and apply this to my cluster, and we'll watch it actually run its course, and we'll see the job in action and what kind of behavior you should expect when you're running Kubernetes jobs. So we've got that going here. At the top, I have my job. We can see that it is currently running through all of its completions. I set a goal of 20 completions, and I also set the parallelism of having 2 pods run at the same time, which is what we've seen here. So right now we've got 2, and let's just watch this, keep it going, and see exactly how this job is going to continue working for us. While that's going on, though, you might notice that the job pods that have finished are just sitting here. Is that going to be a problem? And actually, that's not that bad of an arrangement, because when the pods themselves are completed, you are able to do things like look up their logs, or maybe do a describe, and otherwise get a pulse on them and see how they had actually worked, as well as confirm if their outputs are actually there. So for now, we're going to keep watching this particular job run its course. Currently now at 8 completions, so we need about 10 more, or a little more than 10, of course. And a couple of minutes later, we are now at 20 of 20 completions. And we can also see that the pods themselves are, as I mentioned earlier, just sticking around. And now, at this point, I am able to go through and do something like kubectl logs on one of the pods. Here, we'll do the one at the top, and we can see that it has indeed calculated pi to, I believe, 2,000 places here. So that's going to be the log output. I've confirmed that, and we can see here that there are no longer any additional pods being run at this point. So in order to clean up the job pods, all one needs to do, just like with deployments, is just delete the parent job. Now, there is a setting that will allow you to determine how long a job can remain before it gets automatically removed, but by default, there is no such there's no such limit, and so it is going to be up to you to actually remove the job on your own. We'll go ahead and do that right now by deleting the YAML file. Once that's been removed, if we take a look, we see that there are no more pods, and also there are no more jobs there. And those are the basics of Kubernetes jobs. There are some additional features that jobs are going to be subject to, such as a schedule through another controller called the cron job. And of course, there are a myriad of other settings that you can use to help customize your job runs. So Kubernetes jobs are just one of the things that we at ArcXM are offering to teach for our classes. If you wanted to participate in some of our training, you can always go to rxm.com, and while you can peruse our existing course catalog, we also have the custom course builder in case you wanted to create your own class so that you can actually make your own custom learning solution here. So once you're in the custom course builder, you want to go down and under the category that you want to look for Kubernetes in our case, look for the batch jobs module, drag that over, and select anything else from our other modules here and help build out your course. I've been Christian Lacsina with RxM. This has been another RxM Cloud Native Short Take. Thanks for watching.